All right, let's go through a couple examples of the types of problems we're going to be covering. We're in section 4.3, 4.2 today. We're kind of mixing the two together like we've been doing the last couple days. Last major day of note for these two sections. There's going to be some other sections we're going to go on with this stuff. We have obtuse angles and other things we're going to cover today. Obviously, we're dealing with the trig functions, but we have a couple new things I want to cover today. Number one, the first type of problem I'm going to cover today, we have to do a Pythagorean theorem problem. Hey, I don't need comments right now. Okay, Pythagorean theorem. I want to cover that one first, do an example of what you're going to see in the homework. I'll give you some numbers that are pretty realistic. I'm not going to promise you that your answers on those particular problems will be perfect square numbers. They're not. I can already tell by looking at some of the book problems. So you can leave your answer as a square root, as long as you simplify it down if you can. The numbers are relatively small. They're not going to be huge numbers. All right, that'll be the first type of problem, and again, we're going to do an example of that. The second type of problem is something new. We haven't seen this before. We're going to be doing, I shouldn't say we haven't seen it before, we haven't seen it in here anyway. We're going to be doing the special triangles today. I will leave these triangles on the board. In fact, when I add this to the website tonight, I'll make sure I post both special triangles on there with pictures. So I want to make sure that you know how to do it. We're going to do an example or two of the actual special triangles. So I have two picked out, and I want to make sure that you know how to solve it. And I think it's pretty straightforward what they're going to ask you for. The last couple things we're going to do, and this is, again, something new, we're talking about cofunctions. We haven't actually seen this before. I want to make sure that you know what a cofunction is. That is not a reciprocal. That is not an inverse function. It is something different that I want to at least talk about. I don't think I assigned any of these today, but I do want to talk about it because we'll need it for the later sections. And this is the section where it actually introduces it. So I thought that was kind of easy to look at. We'll look at an example or two of a cofunction. And this is the part, this one in particular, in fact I'm going to put a little box around this. This part in particular is something that confuses people from year to year. Is that one, is the cofunction. Because they keep thinking about reciprocals, they keep thinking about inverse functions, they can't keep it separate, like what does cofunction actually mean. So when you list this in your notes today, be very clear on what we're doing and how we're supposed to do it. Okay? Alright, then the last thing we're going to do is we'll do a story problem. So we'll do an example of the story problem. And the story problems are pretty straightforward. It's basically the thing I've been doing the last couple days where I ask you to like draw a water tower and put numbers on the picture, and we have to find a certain number. So it's nothing like crazy that we're going to be doing here, nothing super difficult. But again, the story problems I picked out of the book, they have pictures. And they'll just ask you to find a certain angle on the picture, so it's pretty easy. You just have to look at what they're asking for. So it's not like you have to interpret everything from words. They actually give you the picture with it. Okay, but this is kind of our detailed notes. I'm going to go through kind of one of each type. When we get to the cofunctions, I might have to do more. Just if I get a feel like you aren't getting it, so we'll have to talk about it. All right, but let's go to the Pythagorean theorem problem. So what I mean by this problem is they're going to give you a triangle, and yes, they do give you the pictures of these. And they're going to put numbers on the triangle. Like for instance, they're going to go, I'm just going to stick with something easy. They're going to go 3 and 5, and they want us to find this wall. Okay? Well, it's a right triangle. I don't have any angles other than the right angle in that triangle, so I wouldn't need to use the trig functions. I could just do the Pythagorean theorem, and I know most people know the answers, because this one's got the easiest triangle we have. But again, how this works, when you do the Pythagorean theorem, A and B have to be the two legs. The legs are the walls that touch the 90-degree marker. I don't care which one's A and B, you can flip-flop them. The hypotenuse has to be the C number. Hypotenuse is always the letter C. And for the Pythagorean theorem, here it is. A squared plus B squared equals C squared. So that's your Pythagorean theorem. Again, it only works on right triangles, and the A and B have to be the legs of the right triangle. Now, I don't care which one of the three, A, B, or C, is missing, as long as you know how to solve for it. So like in my case, I'm missing the letter A. Again, I don't care which one was A and B, but because the legs are A and B, they can flip-flop. But the B is a 3, so I have to square that. And then C is the 5. And yes, you do have to square them. Now, on the video yesterday, I did try to explain, like, common sense-wise, why you have to actually square these. We're actually going to look at the proof later. That's something that we'll look at, like why is it a squared plus b squared? Why isn't it just a plus b plus c? Or a plus b equals c? I talked about in the video, it's based on the rule of triangles, that when you walk around the block, that should be a longer distance than somebody walking a straight path home. That's why you can't just go a plus b and equals c. Because c should be a shorter path. Should be less steps. Okay, but anyways, this is x squared plus 9, because I squared the 3, equals 25. You would subtract the 9 across, in this case, because I do need to get x by itself, which is 16. And when we take the square root to the other side, the square root of 16 is 4. Now, I know when you take square roots on equations, you're supposed to have a plus or minus sign. I'm not going to use the plus or minus sign because we're talking about distances. Distances don't make sense negative. So we just throw that out.
If you have a negative 4-yard rush, so.
In terms of actual walking distance, I'm not talking about football and their stats that they talk about. Okay? All right. Questions with how to do the Pythagorean theorem. Are we comfortable with that theorem itself?
Yes.
Do I need to do another example of it?
No.
Perfect. Moving on. Okay, and again, if you haven't already, try to write down examples today so you know exactly how to do your homework. Nothing's worse than me doing 10 examples and somebody doesn't know how to do the first prompt because they weren't paying attention. All right, special triangles now. There's 2 types of special triangles which you're going to have. Okay, and I'll try to explain the best I can. So here's the 2 special triangles you should have had since Algebra 2 days, including Geometry days. We did talk about these. It's the 30, 60, 90 triangle and the 45, 45, 90 triangle. Now, I don't care how they draw it. They can be flip-flopped. They could be upside down. They could be backwards. It doesn't really matter. They could be rotated. But as long as you know what the numbers are on the triangles themselves, that's all I care about. Now, these 2 triangles will be on the board test day. Like, I'll have them up here, and I'll have that little like PowerPoint cycling through the formulas. If you need them, I'll even have them drawn in case you don't want to wait for the PowerPoint. But on these triangles, the walls are very specific lengths. What I mean by that is the wall opposite of 30 is called the 1 wall, side opposite of 60 is the root 3, the side opposite of 90 is 2. And yes, root 3 is actually smaller than the number 2. That's why the hypotenuse is 2. Root 3 is like 1.7. Now, the other wall for the 45, 45, the 2 legs have to be the same size, and the last wall is root 2. Now, what your homework is going to ask you for, and it's not asking you, like they're not going to give you a wall and ask you to find the other ones. That's what we did in Geometry Lab. We'll do those later. What I'm talking about here is they're going to ask you to find a trig function, a specific trig function for one of those angles, either the 30, the 60, or the 45. They're going to ask you for it. So like for instance, one of the problems I saw in the book was something like this. It wanted to know the secant of 45. And it wants to know the exact answer. That's all it wanted. The exact answer as a fraction. Okay? So that means you have to find the right fraction, or right triangle. So which triangle am I using? The 45, because I'm using a 45-degree angle. So it tells me which triangle I'm using. And now secant is actually the reciprocal. This is the reciprocal of cosine. So if it's the reciprocal of cosine of 45, yeah, is so cosine of some angle is adjacent over hypotenuse, right? That in SOHCAHTOA, the Ka formula is cosine. Well, what we're doing is we're doing the hypotenuse divided by adjacent. That's what we're doing for your 45-degree angle, because that's the reciprocal of cosine. So I just have to pick one of these angles, so I'm going to pick this one, and now I'm going to do the reciprocal of it. So the cosine is adjacent over hypotenuse, so we're going to flip-flop. The hypotenuse is root 2, and the adjacent is 1. That's your final answer. Leave it, move on to the next one. Does that make sense? It should be an easy, you read off the value, you move on to the next problem. Okay, let's do another one, because I said I want to do a couple of these just to make sure you know how to do them. Let's do another one where instead of asking for like secant, they ask for 2 things. So maybe they want the sine of 30, and they want me to multiply that on the cosine of 45. So they want us to actually multiply these together. And they want the exact answer according to your textbook. Use the special triangles, find the exact answer for the following, I think they call them expressions, trigonometric expressions. So, the sine of 30. Well, sine means opposite over hypotenuse, right? And we're going to be using the 30 as my angle. So the opposite of 30 is 1, the hypotenuse is 2. So this is 1/2, right? That's the sine of 30. I just put the 1/2 there. Don't put the sine out front. The answer is half there. And I'm now going to find the cosine of 45. Cosine of 45 is adjacent over hypotenuse. Well, I have to do the 45 angle. Adjacent over hypotenuse. 1 over root 2. So my answer, if I were to actually multiply across, like multiply these two things together, this is what I get. Get 1 over 2 root 2. If you want to simplify that further, you can. I'll have probably that written on my paper, so I'm checking to see did you actually get the right answer. But I know the book says if you want to check the back side, I did give some odds every now and then. On that particular problem, you might need to like get rid of the radicals. So it's called rationalizing, so you need to multiply by root 2 top and bottom. So it actually turns out to be 1 root 2 over, when I multiply these together, I get root 4, which is 2. So it looks like the bottom turns out to be 4. So if you check the back of the book, this is what they might have that. I'll have this written down. That is the answer. But if you check the back, maybe they don't have that. Maybe they had root 2 over 4.
Original answer's 0.37.
And again, I think they want exact answers. They did not ask for decimals, so they want you to leave it a fraction. Now the whole point of them doing this is they're trying to get you familiar with the special triangles again, but the whole purpose of this is just to know what sine is, what cosine is, what secant, what cosecant is, what cotangent is, really quickly when you look at a triangle. Can you set up the fraction in the first place? They don't want to trick you. They just want to see, can you set up the fraction correctly? Do you know the acronym and what it stands for? And do you know what cosine? So when you're plugging these in, I want the fractions, and they can give you the answer. They could be asking to multiply, they could ask me to add the two fractions together. So you have to get common denominators, all that good stuff. Okay, questions on those? That's probably the hardest problem I think of the homework, is that one. Just because it's just so alien that you have to like, they give you the triangles and they ask for the trig functions from it.
How do you spell SOHCAHTOA?
SOH, CAH, TOA.
OH, and so,
Uh-huh.
ka,
Uh-huh.
AH, and then toa.
Yep.
So these three will help you find even the reciprocal ones.
I don't understand.
Reciprocal, so if we do the secant, secant is always paired with cosine, so that was apparent. Well, it's basically you're finding cosine's answer, you just flip it over, it's a reciprocal. That's the only difference.
Your O's and A's
Okay, let me
come
write
with the
that
same
down.
reason.
Yeah. So again, and I'll even pair these. Secant is paired with cosine,
How do we know what we
cosecant
use?
is paired with sine, and cotangent is paired with tangent. So basically what I would do is just find like the tangent answer, and then just flip it over if I want cotangent. That's the easiest way I would do it. But yeah, these are the pairings for all the reciprocals. And you will need these for this type of problem. Because they'll ask for secants, they'll ask for other ones. And basically I start with easy ones from the beginning, and then they get a little bit harder and harder as you go. Now I consider this one kind of a challenging one, because you do have to find both answers and both find together.
That's kind of hard to read up there.
Yeah.
So,
Maybe you should move closer.
not the best pen to chip.
Secant.
Secant is paired with cosine, cotangent with tangent, and then cosecant is with sine. Every trig function is paired with one that starts with the letter C.
Cosecant.
Again, these are called the reciprocal functions, so that's kind of the main
So
difference.
the only thing is they're just flipped over?
Yeah.
And then when do we know, like, when to use the reciprocal?
When they ask for like secant, you'd have to do the reciprocal. So you're flipping that fraction over. You're finding cosines, flip it over.
But unless they,
If they don't ask for it, then you just leave the fraction on.
oh, okay.
So it's pretty easy. Okay, we go with those special triangles. Again, they are in the book. They are right above your homework page, so you don't need to worry about like finding them or having it written down. They are on your book, like right above the homework if you need them. But again, this section is usually one that most people kind of figure out. Once you do like one or two of them, you get the feel for how those work, because they're trying to get you familiar with those triangles again. We're going to use those in the later sections. Like I think section 4, 4, 4, 5, we have to use the special triangles all the time. We'll see those starting Monday. All right, cofunctions. Let's do that. I'm gonna get rid of all these. All right. All right, this is the part that I said is going to confuse some people, so I want you to take super detailed notes on this next part. Argument error?
Yeah, where's that?
Maybe you typed in something. Okay, I've never seen that before. I've seen domain errors, I just don't know argument errors. Maybe
Do you know what
lots
syntax error is?
of syntax, probably the way you're typing it in. You forgot
Overflow
parentheses.
and stat.
Okay. All right. Okay. The next part here. What I want to cover. I want to cover cofunctions. Now this is different than reciprocal. It's different than the inverse functions. Now if you don't know what an inverse function is, inverse is when you're given a triangle like this, and they want you to find an angle. That's an inverse function, right? Like I would be doing cosine of theta is 3/5 adjacent over hypotenuse. And then to find theta, to find the angle, you do an inverse function, right? This is an inverse, or what we call an arc cosine of an angle. And when you type that in your calculator, it gives you angles, right? And you can type in 3 divided by 5, whatever that decimal is, but the inverse cosine, the cosine -1 key in your calculator, you have to always hit like the second key. This is called an inverse function. That's what the little -1s mean. They are not the reciprocal functions, right? It's not, doing cosine of -1 is not secant. It's not flipping the fraction over. It's finding the angle in the corner. This is different than what I'm about to show you. Okay? What I'm talking about is called a cofunction. A cofunction is something that if you were to type up in your calculator, it would give you the same exact answer. What I mean by that is like, when you type in certain things in your calculator, like let's say the sine of 30 degrees in your calculator, and you're actually to type it in and hit enter, it would tell you like 1/2 on your calculator. It would tell you 0.5, right? Because it's pre-programmed to know what those are, okay? But there's such a thing as called a cofunction that if I were to type it in a calculator, it would give me the same result as that one. And what you do here is that every trig function has one that it is also paired with, that when you type it in the calculator, it will give you the exact same result. Not a reciprocal, not an angle, but the same exact answer. And how you do this, sine and cosine are always paired together. They're like the main two trig functions everyone always thinks of, sine and cosine, right? They're paired. So what you do is you take 90 degrees and you subtract 30. You subtract whatever your angle is. It's always 90, and you always subtract whatever the angle they gave you originally. So if you were to type in cosine of 60 on your calculator, it would tell you the exact same result.
You think so?
It would give you 0.5 on your screen, or half, if you have a nice
It is 0.5.
0.5. It's called a cofunction. Now, I know this seems really stupid and silly. There is a purpose to having a cofunction. It can make angles smaller, because obviously you're taking 90 minus that angle, so you're getting smaller angles. But also, if your calculator doesn't work anymore, and I'm not even joking, this did happen to one of my students in the previous years. Their calculator, they just borrowed one from their brother and sister. One of the buttons honestly didn't work. I think it was like the tangent button didn't work. You can actually do a cofunction and get the same result if you had that button on your calculator. And they were lucky enough they had one of these. They borrowed it. And so there was, in the menu, there is the cotangent. Cotangent and tangent are paired together. Even though they're reciprocals, they are also known as cofunctions. That when you type them in the calculator, there's a way that you can get the same answer. So sine and cosine are paired together. Secant and cosecant are paired together, so they would give you the same result. So let's say I give you like 20 degrees for secant, on a calculator, that would be the same as doing 90 minus 20 for cosecant. And that would give you the same result. Now the problem is you guys don't have that button, so it's something you couldn't type in. You guys don't have the luxury of that unless you have a nice graphic one. But then tangent and cotangent are paired together. Even though those are reciprocals of each other, they're also known as a cofunction. So let's say this is 40 degrees, you could go 90 minus 40. And it would actually give you the same result, the same decimal on your screen. It's kind of cool how it works. I know it seems silly right now, but there is a purpose for doing that because it can make your numbers smaller and you can find trig functions for smaller angles. Okay, is there any questions with what a cofunction is? Now, the book, I don't think I signed any of these, but what the book asks for is that they give you a trig function, all they say is find the cofunction that will give you the same result. So all they want, if they gave you the sine of 30 on your book, and they said find the cofunction, they just want this one. That's all they want. They don't want the answer. They just want to know what cofunction could you type in that would give you the same result. Does that make sense? So sine and cosine are paired, secant, cosecant, tangent, cotangent. It's always 90 minus whatever the angles. Now, if they give you it in radians, like in any angle today it's in radians, just convert it back to degrees. Just do your normal thing. Okay, just transfer everything back into degrees, 80 over pi,
Yeah, Mr.
180 over pi.
Mr. Griman told us that you can have some people put in
Oh yeah, yeah. We're going to look at those later, like when we get to the later sections, like I think it's section 4 and 5, we'll start dealing with more radian angles, and we'll start showing you how you can convert on a calculator, and how I just avoid it. I just always convert things back to degrees, so don't worry about it. But yeah, and we'll talk about how to switch things. Okay, all right, story problem today. In fact, I'm going to just use this problem as my story problem. Let's say that the question was find the angle of elevation. Find the angle of elevation to the top of a building given the following numbers, right? So this is what we're trying to find, the angle of elevation to the top of the building. We're given the following numbers. So maybe this is 3 meters. You're saying 3 meters from the building. The ladder you're using is 5 meters long, and that's the ladder going up to the top of the building. And you want to find the angle that you're making with the ground and the ladder. So that's called an angle of elevation. So looking up in the air. Okay, angle of depression is when you're looking like at the horizon in an airplane and looking down. On the video yesterday, we talked about the angle of depression. Let's say this is 12 degrees. That's the same as the angle of elevation in the triangle, because it's alternate interior. But again, this would be like a story problem. You'd actually have to type that in your calculator and actually give me the result. Your calculator does have to be in degree mode for you to work that. You have to hit the second key and type in whatever trig function they're giving you, and then type in the decimal or the fraction after it and close the parenthesis. So the inverse cosine of 3 divided by 5, now close the parenthesis, and my calculator tells me it's 53 degrees.
5-3.
So about 53. And then, if you look at your picture, yeah, it's got to be in the ballpark. It's got to be something less than 90. So if you're getting weird numbers on your calculator, maybe you typed in your wrong.
How did the Casio do that?
The Casio's can't close at all.
Okay. All right. Questions? Questions on any of the types of problems I've given you today?
Nope.
Okay, here's your homework. The homework that I'm going to give you today is due next Wednesday. So I'm giving you some days to work on.
Just a couple.
So it's gonna be hard then, right?
No, it's not.
It's gonna be talking, but we defeat.
All right, here we go. Page 498. 498. We're doing problems. Number 4, number 5. We're doing 10 through 20, the evens.
Oh my.
That is a lot.
We're doing 30 through 33. And then we're jumping to the story problems, which are these.
We should just take the story problems out of there.
Story problems are the normal trig functions, so we gotta do those.
Yeah, but
Everything else is like something specific, like do Pythagorean theorem, or find the cofunction, or find an angle. But then the story problems are like do a normal trig function, find the height of a building. So,
Jimmy, do you think there's a dab error on the calculator?
alright, there you go. Okay, again, I'm not blaming any of you, because I don't know if it was you, because I don't know, but I need calculators back if you borrowed them. I'm down to 4. And I started with 10 as of Wednesday morning. So they went missing at some point.
Some people are just scumbags.
So,
How would they do that?
just make sure, if you know where they're at, make sure you give them a return.
I
Yes,
think you're a
okay.
suspect. I do.